time. And then going live now, I hope. And we have attendees coming in now. They can't speak as a reminder for everybody. Just the panelists can speak, and so they will be coming in. So I'll give it another minute or so. Maybe we should start. So welcome everybody. This is Sheila Heyman speaking, and welcome to the Ecopath online seminar series. As I said, it's 6 o'clock Central European time, and currently only 10 o'clock in Canada. It's very disturbing to me that we don't change time on the same time, so it's a bit confusing. So sorry about that for the people in North America. Just some housekeeping rules. Please make sure that your name is entered so that when you write a question, we will know who asks the question. And if you have any problems, please put it in the chat. I will try to see if I can fix that. Please be aware that the webinar is recorded and it will be available on our YouTube channel and on the Ecopath YouTube channel. And it is being live streamed, hopefully, on Facebook. On YouTube right now. The Ecopath webinar series used to be held every 2 months, but somehow has fallen off the edge of the world for me a bit. And usually it's on the last Tuesday of the month at about 12 noon Eastern time and 6 o'clock European time, 9 o'clock, I think, Vancouver time. And if anybody wants to give a seminar in January, then we do not have anybody to speak just now. So I think the next one, which would be a good time, is the 31st of January. Today we have Andy Stock from the University of British Columbia speaking, and he is going to talk about exploring cumulative human impacts with Ecopath of Ecosim, the state of the art and future directions. And that's all I'm going to say. I think it's probably better that he talks more about that. So I think without further ado, I will stop sharing and Andy can take over.
Hello, everyone. Good morning or good afternoon or good evening, depending on where you are. All right. So now okay, good. Can you see my screen?
Yes, we can.
Perfect. Okay, so I'm a postdoc at the University of British Columbia, where I work in the Institute for Resources, Environment and Sustainability. And I first want to say that work that I'm showing today has been influenced by amazing collaborators and mentors here at UBC, but also at Fisheries and Oceans Canada, at SciTech Environmental Consulting here in Vancouver, the Ecopath International Initiative, and at Stanford University. For almost 2 years now, I've been funded by a Libero postdoctoral fellowship, which provides not only financial support, but is also an amazing intellectual community and provides great training opportunities. I've received additional funding from MEOPAR, that's the Canadian Marine Environmental Observation, Prediction and Response Network. I'm happy to call UBC my intellectual home for the time being. I want to acknowledge that UBC and my private home are located on the traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations. The question that I've been asking is how we might use Ecopath, Ecosim, and Ecospace to study cumulative human impacts. I've been approaching this question through a systematic literature review that focused on applications of Ecopath-based models to study impacts from human activities other than fishing. Why other than fishing? Ecopath is just such a well-established tool for fisheries research that I thought that I have little to add to that discussion. So today I first want to give you a little bit of an overview of cumulative impacts, what they are and why they matter, what do we know about the biology of cumulative impacts. I'll then place Ecopath, in a broader overview of different modeling approaches that have been used to study cumulative impacts. And then we'll dive into the literature review, where I'm going to discuss both the state of the art, what are people currently been doing or have been doing over the last 20 years or so. And I'll also suggest a number of future directions where I feel that those are areas where we can make major progress with tools that we already have available. So what are cumulative impacts? Cumulative impacts are the combined impacts of all the different ways in which people affect marine ecosystems. And we affect marine ecosystems through many different activities. For example, many of the world's fish stocks are overexploited. The International Maritime Organization estimates that about 90% of global trade is carried by sea, and shipping causes some issues with pollution. Sometimes ships collide with marine mammals. It's also a major source of underwater noise. Land-based activities put many things into the oceans that can be harmful to marine life. For example, one study estimated that we're putting several million metric tons of plastic trash into the oceans every year. And then there are many more local human activities like offshore energy developments, aquaculture operation, wastewater discharges from treatment plants that can have local effects on the ecosystem. And of course, all of this is happening against the background of climate change. Figuring out how all those different human activities and the stresses they cause plays out at the ecosystem scale is super complicated. At the same time, it's been identified as one of the most important threats to ecosystems and to biodiversity. And given the complications, understanding cumulative impacts better has been identified as a grand challenge in marine ecosystem ecology, and is a central objective, one of the objectives of the UN Decade of Ocean Science for Sustainable Development. Before diving into what makes cumulative impacts complicated, I want to share a short conceptual model to make sure that we're all on the same page. So in most of the oceans, there are several human activities, either taking place right there or having remote effects, like in the case of climate change. Each of these human activities can cause one or more stressors. For example, bottom trawling, that's a kind of fishing where the gear is dragged over the sea bottom, directly removes fish from the sea. So this biomass extraction is one stressor, but it also abrades the sea bottom. So that would be another stressor. And the same stressor can be caused by different human activities. For example, underwater noise is caused both by shipping and by marine construction works. And then each of these stressors affects different organisms in the ecosystem, and thereby also populations, the biological community, and the ecosystem as a whole. And how cumulative impacts play out across ecological scales depends on a large number of factors. For example, on ecosystem structure, on species interactions, think about trophic cascades, for example. It depends on meta-population dynamics, on connectivity between subpopulations. It depends on biodiversity and functional redundancy. It depends on the presence of ecological thresholds and tipping points. It depends on interactions between stressors. There's been a lot of research interest into interactions between different stressors. Much of this research has focused on the level of organisms. This plot shows results from 4 meta-analysis that summarize biological experiments that each subject different organisms to 2 or more stressors at the same time. And the blue and the orange parts of the bars show how many experiments reported only additive effects without any interactions, and how many reported interactions respectively. And what's striking is that in all 4 meta-analyses, 70% or more of the experiments reported that stressors actually interacted, in the sense that their combined effects were different from just the sum of their individual effects. Another thing that I find really striking in this body of research is that we have so many individual pieces of the puzzle. So this plot alone, and it's not a complete overview, summarizes hundreds of lab studies. But in spite of having all those puzzle pieces, a big picture of how cumulative impacts work in an ecosystem has not emerged. Part of the reason why this has not emerged is that in an ecosystem, there are just so many different things all happening at the same time. What you're seeing here is an illustration of the pathways through which ocean warming and acidification affect selected species and species groups of the west coast of Vancouver Island. I'm sorry, it's probably impossible to read. Or, well, on a screen, you might be able to read this actually, depending on how big it is. Sorry for the small font in any way. So from this, one example of a pathway would be that warming affects the growth of microalgae. And it's obvious that climate change alone will have so many different effects on so many different species on the west coast of Vancouver Island. And we're not even looking at aquaculture. We're not even looking at sedimentation. We're not even looking at pollution. We're not even looking at underwater noise and all the other stressors that are present in these ecosystems. The good news again is that we have lots of evidence. Each pathway in this plot is backed up by at least one peer-reviewed lab or field study. But again, how do all of those known effects play out at the ecosystem scale? We just don't know. How can we build this big picture of cumulative impacts at the ecosystem scale? Because we cannot manipulate ecosystems in experimental designs, and because we cannot feasibly observe all the relevant moving parts that we might need to know about to understand cumulative impacts, I think that modeling must be a major component of studying cumulative impacts. And the next part of this presentation, I just want to give you a very short overview of different approaches that people have been using. The most widespread model-based approach to study human impacts is built on geographical information systems, or GIS. So those are tools for the management, analysis, and visualization of spatial data, and they allow us, for example, to ask where human activities coincide with sensitive species and habitats, and to identify potential hotspots of impacts. There are many studies doing that. I think it can be quite useful in scientific and practical applications, but we cannot go far beyond those kind of footprint or hotspot analysis for 2 reasons. The first reason is that GIS combine data based on spatial overlap and spatial proximity. And in highly dynamic systems, like marine ecosystems, spatial overlap and proximity are not necessarily the best analytical concepts. And the second reason is that in those kinds of models, we have to hard code things like stressor interactions and ecological thresholds in the model assumptions. We have to tell the model if stressors interact. We have to tell the model if ecological thresholds are present. But those are exactly the kinds of things that we would rather learn from modeling than having to know them in advance. Over the last 10 years or so, there have been a number of studies that have tried to get around those limitations based on statistical and machine learning, which I consider to be synonyms for the purposes of this presentation. And the promise here is that rather than making assumptions about how stressors interact, if we have the right data, we might be able to learn these relationships from data. The challenge is that especially in marine ecosystems, we're really, really limited by the quantity and quality of the data that are available. And there are a good number of statistical pitfalls when we're using machine learning on spatial data. For example, the fact that many marine data sets are not collected at random times and locations has major statistical consequences. And that's actually my other obsession beyond cumulative impacts, machine learning methods that overcome those limitations of the spatial data that we have. That's beyond the scope of this presentation, but I encourage anyone who wants to chat about this to reach out to me. And finally, there are ecosystem models, which the rest of this presentation will be about. And I got interested in ecosystem modeling because the ability to simulate ecological processes and to reflect ecosystem properties like food web structure that we know are relevant for cumulative impacts just means that there's a lot of potential. So I wanted to know, well, how have they been used to study human impacts? I started a literature review around 2 years ago now. I searched for this review, I searched several sources for literature. I searched the Web of Science using search terms related, for example, to different human activities and stressors, and also including Ecopath, Ecosim, and Ecospace as search terms. I went through the abstracts of all papers referred to in Ecobase. That's an online database of Ecopath models. And Billy Christensen generously shared his collection of documents that describe applications of Ecopath with Ecosim. Those were about 1,000 PDF files, and it was strikingly complete. Among the literature that I found, I only looked at published journal articles. With very rare exceptions, there were a few cases where, for example, a master's thesis that I just happened to come across would use a modeling technique that wasn't reflected in the peer-reviewed literature yet. So I included 3 thesis and technical reports, I think. I only looked at literature in English. I read the abstracts and the titles of over 1,000 documents, and I only included those in the full review that mentioned a human activity or a stressor other than fishing in the title, abstract, or keywords. So if the abstract just mentioned the word climate change, or if the abstract just mentioned the word eutrophication, or if it just mentioned the word offshore wind, I would read that article in full. I first searched for literature in October 2020, and I updated the search in January 2022 to include the most up-to-date literature possible. And in the end, my review included 163 articles. Those articles came from all over the world, like you can see on the little map on the lower left. They were concentrated in North America and in Europe, although that might partially reflect the fact that we excluded literature that was written in languages other than English. And as you can see on the plot of the right, this body of literature has been growing quite quickly. So before 2005, there were only 1 or 2 papers every year that used Ecopath, Ecosim, or Ecospace to study human impacts from activities other than fishing. In 2021, there were 25. So that's a 10-fold increase. So the first big insight from this review is that this area of research seems to be growing really quickly. Of those 163 articles, 20% used only Ecopath models. And what these studies do is compare food web models, either for different time periods, for example, before and after an invasive species gets established, or along a stressor gradient, for example, at a sediment dumping site in comparison to a control site. The studies have covered many different stressors. They've been used to investigate potential effects of climate change, invasive species, aquaculture, offshore energy, eutrophication. One study looked at effects of urbanization by comparing Ecopath models for a beach right at a city and a similar beach that was a little bit further away and saw much less human use, and many others. Of the remaining studies, 59% used Ecosim for temporal simulations and 21% presented spatial temporal simulations for Ecospace. And the second big insight from my review is that these studies already cover all of the globally most relevant stressors. That includes climate change, mostly warming, but also some papers on acidification. It includes species introductions, habitat loss, eutrophication, pollution, aquaculture, and again, many other different human activities and stressors. It's worth noting that many of those stressors cannot be modeled with Ecosim and Ecospace alone. So we have to draw on inputs from external models, for example, on future temperature projections from climate models, and 22% of the studies that I looked at used external models in that way. And we won't have time today to go into the details of how all of those stressors can be modeled. So I just want to give you a couple of examples. For example, the main idea for modeling aquaculture based on Ecopath is to include the farmed species as compartments in the Ecopath model. And in some cases also include feed as detritus in the model. And then provision of habitat by aquaculture-related structures, for example, by oyster eggs, has been modeled through mediation functions, and the attraction of predators. Conversely, the effects of predator deterrent devices have been modeled, for example, through environmental response functions. Offshore energy has a number of effects. For example, it provides hard substrate that has been modeled in Ecospace explicitly as a habitat, or some Ecosim studies just forced an increase of the biomass of species that are expected to benefit from additional hard substrate. Exclusion of fisheries in Ecospace can be modeled by marine protected areas, and mortality due to bird collisions has been mortality of birds due to collisions has been modeled by not dishing fleets. Sorry, this is a typo. I wish there was a dishing fleet that cleans out my dishwasher every evening. By fishing fleets, There are also a number of studies modeling underwater noise, for example, based on environmental response functions. So in principle, we have this really strong foundation of modeling techniques, and we could build an Ecosim or an Ecospace model that simulates many different stressors at the same time so that we can see how all those effects on individual species groups together work in the food web. And this brings us to the future directions. And I want to be clear that my perspective here comes from my particular background. So on the one hand, I am an interdisciplinary environmental scientist who's most interested in the big picture of how our planet is changing. And on the other hand, I don't specialize in any particular modeling approach. I'm much more focused on general computational approaches in the environmental sciences. So for that reason, none of the suggestions that I'm making now is about actually improving the Ecopath or Ecosim or Ecospace. Because I think that for my purposes and from my perspective, those are already really amazing tools. The suggestions that I'm making instead are more about the questions that we're asking of our models and how we use the models to answer them. So I suggest 4 potential future research directions. I'll list them now, and I'll explain each of them in a little bit more detail afterwards. The first direction is to represent many stressors and their pathways and effects in Ecosim or Ecospace models. The second one is developing best practices for extracting environmental response functions from data. The third one is relating ecological impacts to human dimensions of environmental change. The fourth one is making use of computational experiments to disentangle the effects of multiple stressors in a model ecosystem. It turns out that even though we can include so many different human activities and stressors in Ecosim and Ecospace models, 57% of studies looked only at a single human activity or stressor. A bit over 30% looked at 2, 10% looked at 3, and only 2% looked at 4 or more. So at present, we're not using the potential that Ecopath-based models have to simulate many different stressors at the same time. But what might be less obvious is that if we want to understand cumulative impacts, we might also need to consider the many pathways by which each stressor is known to affect the ecosystem. And to remind you, this slide shows the conceptual model of all the known pathways by which climate change is known, true warming and acidification is known to affect coastal species groups on Vancouver Island. And each pathway is backed up by empirical research. Among the over 160 studies that I reviewed, not a single one discussed, not a single one included a comprehensive discussion of these pathways. So moving forward, I think that if we want to understand the ecosystem scale effects, even of how single stressors play out, it would really be worthwhile to try and represent as many of these pathways as we can in the models. These kinds of pathways of effects models, they can be tailored for this purpose. The model that you're seeing, for example, the species groups at the bottom, they are lined up with an existing ecosystem model for the region. And the challenge then, of course, is to translate all those different, very nuanced effects that have been found in ecological research into ways that we can represent in Ecopath. The second direction for future research is the development of best practices for deriving environmental response functions. So in Ecosim and Ecospace, we can use those response functions to link changes in a stressor or in environmental conditions to changes in the foraging of the species group. And I want to clearly say first that this is a little bit different from the other directions that I'm going to suggest today, because there is already a good bit of discussion in the literature on how to do this. So it's widely known that getting those response function right is really important. Just to give an idea of what they do, so this plot shows 6 different response functions that relate the foraging of the Dungeness crab to water temperature. And those are 6 functions because I'm using 6 different approaches to derive this. So they have 2 functional forms, trapezoid shape and a Gaussian shape. Both are quite common in the literature. And those are parameterized with data from 3 different sources, 2 global databases, Aquamaps and Sea Life Base, and Friesen et al., which is a local study from British Columbia on climate change impact. And you can see that they are quite different. It really matters which one of those we choose. In the literature, there were 3 ways to build response functions. In some cases, we can build them on experimental data. For example, there's been work modeling impacts of oil spills that use published dose-response relationships for key species. In some cases, we can build them on qualitative conceptual models. For example, one study built a response function for marine mammals for the effect of noise on marine mammals based on observations of changes in feeding behavior. And finally, that's the most common, we might use information about species ranges or distributions to infer their response to different environmental variables like temperature. But it's also possible to do this for a much wider range of stressors. So in my other line of work, statistical modeling for spatial data, I'm working to extract such functions from different ecological data sets. And I've had quite mixed success so far, I must say, but there are a number of studies that had access to really good data that have been able to make this work for a wide range of stressors. What matters most, though, in my opinion, is that as a community, we come up with best practices to build these functions in the future and to understand how the choice of those functions actually affects model outputs. The third direction is a better integration of human dimensions. So my main interest in cumulative impacts is about how people change ecosystems. But ecological changes in turn affect people, for example, if important ecosystem services are diminished. So when going through the literature, I explicitly looked out for ways in which human dimensions had been integrated. And I found few, but quite inspiring examples where that had been done in really nice ways. These examples together suggest three kind of natural interfaces where we can integrate Ecopath modeling and human dimensions. The first of these interfaces are the indicators that we're looking at. In the literature, the most reported indicators in Ecopath studies and Ecosim. When I say Ecopath, I mean this to include the whole modeling platform, including Ecosim and Ecospace, by the way. So in this literature, the most commonly reported indicators are changes in the biomasses of species groups. The indicators describing ecosystem structure and function were also quite common. So those are indicators like the cycling index. And about 1/3 of studies reported indicators related to extractive ecosystem services like fisheries catch. But only 3% of studies reported indicators that were related to non-extractive ecosystem services like carbon sequestration. And these were in most cases quite basic proxies. For example, one study used phytoplankton biomass in an area with blooms and water quality issues as a proxy for coastal recreation potential. And it's actually quite smart, but we can go beyond that. I found one single study that valued non-extractive ecosystem services in monetary terms. And that was led by my colleague Ed Greger here at UBC. So that study used approaches from environmental economics to put dollar values on different ecosystem services. It included carbon sequestration based on the social cost of carbon, and it included wildlife tourism based on a willingness to pay study. So in this way, that study was able to show that reintroducing sea otters in British Columbia, which happened in the 1970s, but is still controversial because of effects on fisheries, that in this introduction, overall, the economic benefits outweighed the costs. The second natural interface for integrating human dimensions were detailed socioeconomic scenarios. So many studies investigating the effects of climate change built on IPCC scenarios, but for other stressors than climate change, those scenarios tend to be rare. The exception were several quite interesting studies from the Baltic Sea region that could build on previously published socioeconomic trajectories for the region. Developing good stressor scenarios, I think, is a crucial part of understanding cumulative impacts on ecosystems. And the third interface are community workshops. So Ecopath-based models have been used in workshops in other contexts like fisheries or in the MSP challenge. But I found a single study that reported a kind of comprehensive socio-ecological research program that was based on workshops where models were used to link environmental changes and community concerns. Regarding all three interfaces, what's worth noting is that all of those studies only came out in the last couple of years, so that's definitely an area with potential for growth. The fourth direction, where we can make major progress with tools that are available now, is how we're designing our modeling studies, or the research designs that we're using. So a research design is essentially the logical framework or plan that we use to answer a research question. And it involves questions like, well, what is our question? What evidence do we need to answer? Is how do we get this evidence? Once we have it, how do we analyze this evidence and so on? So in the literature, 4 major research designs have been used. Over half of the studies that I read employed scenario simulations. And this means that simulations are repeated for a rather small number of scenarios, for example, a handful of climate scenarios in combination with different levels of fishing. And the results from those scenarios are then discussed qualitatively. About 1/5 of studies used historical simulations, which aim to reproduce and explain past environmental changes driven by one or more stressors. And the major difference to scenario simulations is that we do have the benefit of hindsight, and we do have access to historical data for the period that we're actually studying. Another 18% of studies compared static ecopath models representing the ecosystem at different times or along stressor gradients, and we already briefly speak about those, so I'll leave it at that. Only 3% of studies used a systematic experimental design, namely factorial experiments. The advantage of such formal experimental designs is that they allow us to quantify the direct effects and the interactions between different stressors. But the issue with factorial experiments is that they are actually designed for lab experiments where every repetition is a lot of work and might cost a good bit of money. So they are designed for situations where we can repeat our experiments maybe a couple dozen times. But one of the most powerful things about computer-based research is that we can, in principle, repeat our analysis thousands of times while making controlled changes to the inputs, to the parameters, even to our modeling assumptions. And we can see how much these changes affect the outputs. And this opens up unprecedented statistical possibilities. For example, if we have an ecosystem model that can simulate many stressors at the same time, we might be able to use this to generate big data about a hypothetical ecosystem. Then we might be able to analyze these data with machine learning approaches or with more traditional sensitivity analysis approaches that are designed to disentangle the direct and indirect effects of many different variables. The downside of this is, of course, that we're exploring a hypothetical ecosystem, but not a real one. But this could be a really great engine to generate hypotheses that could later be tested empirically. And this is feasible. There are already a good number of studies that use Monte Carlo simulations for uncertainty analysis. And while what I'm proposing here is a little bit more involved, it's not fundamentally different. But I haven't found a single study that makes use of this potential so far. So where does this leave us regarding the state of the art and where we might be going next? We've seen that we can investigate many human activities and stressors using Ecopath, Ecosim, and Ecospace models. And that this body of literature is actually growing quite quickly. So it's fair to assume that these methods will be further refined in the near future. So I'm convinced that Ecopath is already a really strong technical foundation for studying cumulative human impacts. And I'm really grateful to all of you who have helped to build this foundation. But I've also identified 4 areas in which we might be able to make progress by combining Ecopath modeling with existing approaches from other disciplines. That includes the vast body of empirical knowledge about individual stressors' effects on individual species. That also includes progress in spatial data science and computational statistics, and methods from the social sciences for human dimensions. I'm currently applying for funding and for permanent positions in which I would hopefully be able to continue trying to make some of these ideas work. But I think that there's just so much potential, but also so much work ahead that I would really love it if other folks were to build off these ideas and also improve them through their own perspectives. So in that spirit, I'm really looking forward to questions and a discussion. Thank you very much.
Thank you very much, Andy. That was great. Let me just see if I can see everybody. There we go. So thank you for a great talk there. We have on the panel today Willy Christensen, Jeroen Steenbeek, Kim de Muster, Lee McGolty, and Christy Lewis. Sorry, I'm terrible with the last names there, Lee. And I think I will just open up to questions for the people who are watching this. Please, if you put your questions in the Q&A, I can read them out. But in the meantime, I'm assuming people from the panel will have questions, right? I'm not seeing any hands raised by you guys. Kim, go.
Yeah, great presentation, Andy. I liked how you showed how many different stressors can play a role in a system, right? So I was wondering, do you have any recommendations on when to stop adding additional stressors in your model? Like at some point you may have autocorrelation, or it may not add much more information. Do you have any recommendations perhaps on how to deal with that? Like what would be the most ideal representation in a way?
I don't have recommendations yet. I think there are some examples where looking at a single stressor gives us misleading conclusions. But that's not necessarily always the case. And I want to be clear that asking what is the effect of an increase in primary production on this ecosystem, I think that is totally legitimate. It's not a question that I'm most interested in, right? So for what I'm trying to do, I think we have to look at a really comprehensive set of stressors, and because this has not been tried before. I can't say how many we need to look at. It would definitely be worth trying. Regarding the pathways of effects model for climate change, I will try this winter to see how many of these pathways I can actually add to an existing Ecosim model, and then I will run it with like basically random subsets of the pathways and see if adding all of those pathways actually makes a difference in the conclusions that we're drawing.
Great, thank you.
Jeroen?
Hi, Andy, nice work. It's very nice to see this comprehensive overview of what's been done so far, and it's rather encouraging that that the amount of cases is on the increase, right? So, I mean, not always lost or anything, but in your review, do you also find the reasons why multiple stressors inclusions are not done, or why systematic executions are not done? Because yeah, the literature often tells you what has worked, but you never really hear what did not work. So I'm curious to see with your review what you run into.
I cannot say why people have gone down the path that they have been going with their studies. I would guess that it has to do with intellectual traditions, with disciplinary traditions, because I think that many folks working with Ecopath are ecologists. And if you're taking a statistics class as an ecologist, that tends to be more focused on doing statistics for lab experiments, for field data, and so on. So it might be that people simply haven't been thinking of those approaches, haven't had them on their radar. That could be one explanation. The other explanation could be that it involves technical challenges. So, you know, linking to the code of Ecopath and working on .NET, that's also not necessarily a skill that that many ecosystem modelers learn during their education. So I think there might also just be this technical barrier of essentially putting it into a big for loop and having to work with the source code and so on. But you might have, you know, you're the .NET guru here, so you might have more insights on that.
Well, but for that, I was more curious to see if you got any pointers in the literature, because I mean, I have my own preconceived notions about this, and I did a comprehensive study about the technical gaps we're having. But it's just interesting. Is it people blame data? People blame connectivity with other teams? I mean, it is true that as an ecosystem model, you need many different hats on. But
yeah, no, in the literature, I didn't find studies that blamed specific things for approaches that they didn't try. So,
okay, well,
I would love to know, but I don't.
Thank you. Thank you.
Okay, Christy, and then Willie.
Hi, Andy. Great talk. I think these types of summary review papers are really, really important. So thanks for the work you're doing on that. I was wondering if you could flip back to your beginning of your presentation when you talk about the stressors that you're talking about, if you wouldn't mind.
This will take a moment.
Yeah, for sure.
Okay, so both know.
Okay. So I see. So when you were defining your stressors, were these the groups that you were looking at? These were the 5 groups of stressors that you were looking at?
No. So those, sorry, I should have been more clear about this. So those are just examples of different stressors that are important, right?
Okay.
So
climate change. Oh, sorry. Go ahead.
Yeah. So in the actual literature review, I went through 2 rounds. I first included search terms related to stressors that I know matter because there's plenty of literature on them using other approaches, right? So acidification would be a keyword, warming, temperature would all be keywords, aquaculture would be a keyword, species introductions would be a keyword, and so on. And then once I had this initial body of literature, I actually went through and looked for additional keywords on there to make sure that I'm catching some synonyms and so on. Sure. But the categories that I then used, so back here, the categories that I then used, they actually emerged from the literature. So there's like one collection of papers that studies aquaculture with relatively similar approaches. So that's why this is a separate stressor category in here. Mm-hmm. And it's absolutely true that the numbers in this plot actually, they depend on the categorization that we're choosing. There's not a very widely accepted categorization that works in all cases. There are challenges related to, double counting. For example, sea ice loss, is that climate change or is that habitat loss or is that both, right?
Right.
So we've tried to be really consistent in that. But yeah, this really affects the numbers that we're finding here. But the main message that we can actually include, we know how to include many different human activities and stressors in these simulations. I think that's not affected by the categorization that we're using here.
Okay, so like if you were to have a climate change effect, say on temperature, and then another stressor of reduction in salinity, would you consider those multiple stressors? Or would you consider that a physical climate change or something like that? So I'm just trying to understand your categorization of what you mean by multiple stressors. I think that's where I like some clarification.
So physical changes, salinity, temperature, and climate change. Yeah, for example, salinity and temperature in the context of climate change, I did count that as one stressor. Physical climate influenced conditions. And if it's temperature and changes in nutrient inputs related to eutrophication, in this categorization framework, that would have been counted as two stressors.
Yeah. Okay. Well, no, I appreciate that. I mean, I don't think there's a right way or a wrong way to do it, but when I'm thinking about building models myself, I think about each of those individual environmental parameters as a potential stressor itself. So yeah, I just wondered how you classified it. So I appreciate it. Nice work.
Yeah, I think that would what it would do in the results that I showed today is that doing this would bump some of the one stressor papers into the two stressor category and some of the two stressor papers into the three stressor category, and so on. I don't think it would really change the overall picture, but that's a really important caveat here. So thanks for pointing this out.
Yeah, nice work. Thanks.
Billy?
Hi, and thank you, Andy. It's great to see how this both the paper took shape and also the presentation. And I was actually hoping that, I'm not quite sure if Sheila, did you share the link with the participants?
For the paper, no, but I can if you want me to.
I think it would be useful to share that link for the preprints. And one of the things you talked about was technical difficulties in, for instance, in running many runs. We have for years had some rather unused approaches for that in the forum, or we can go in and make plugins that makes that quite feasible. We've used that a lot, but it's not something that's been more generally used. But maybe because of the take up, you have to get in, need to know about .NET in order to do it. So there are other activities in progress now that are looking at this activity here, or this issue here. June and I were at a European Commission meeting last week for the Ecosim project, where Jeroen has worked with colleagues in Holland to put up, to get together a Python script, a way with Python notebooks to be able to run multiple runs of multiple models in a fairly neat way, a really neat way. And that facility is now being developed, applied, and the expectation is that it will be something that can be generally used. And in addition to this, Howard Townsend from NOAA was there last week, and we talked about this, and he's really keen to see parallel activity in R. So there's quite a lot of effort going into how you run the model just from scripts instead, so you can get rid of the reliance on the interface. So that's one thing that will help address that issue that you talked about. And of the things you talked about, I also like to pick up this thing about the environmental preference functions, which are really key for describing what is the impact of the stressors that you're working on. And yes, they are critical. And if we use general databases like APRAMAPS, we're getting some really broad ones, broad functions, because they cover the complete distribution of a certain species, which when you compare that to local studies, where there's local adaptation, you are in a situation where, yes, you should really use those local adaptations to understand that level. So it's an issue that we are struggling with, and it's really nice that you're highlighting it. And it's one that we definitely need to see more research on. There was no question there. Sorry for that, but comments.
No, super great to have this update. I mean, one of the challenges with the review is that as soon as it's published, it might be, you're not covering the most up-to-date developments anymore, right? So great to have this edition. Thank you.
Thanks. Jeroen, I'm going to, did you want to come in on that? Because we have a question in the in the question and answer, but if you have a follow on, then you can.
I'll quickly follow on to this. Yeah, Andy, of course, it's impossible to stay actual because the moment you write something down, it's outdated. It's just inevitable. We're working on several activities that will make this even easier, like turning the computers around you into a de facto computing cluster for doing systematic analysis and those kind of things. What I wanted to so there's lots of things going on. We're bringing contaminants into the picture to as other active factor to drive the ecosystem and to make life of the ecosystem difficult. So there's lots of things we can do, and I'm looking forward to playing more with this, with you included. Shira.
Thanks, Jeroen. Okay, so the question is from Ibrahim Alamadina, who says, great presentation. I will have to say that I agree, but he says, given that most studies only look at one or two stresses at the same time, how appropriate is it to populate multi-stressor models with their stressor response functions? Wouldn't that neglect potential interactions?
So yes and no. So interactions can arise at different ecological scales, right? So they can happen at the organism level. Example would be higher temperature leading to higher metabolism, which leads to faster uptake of toxic substances that might be in the water, right? So this happens at the organism scale, and this is something that we would need to tell our Ecosim or Ecospace models, and we need to kind of code it in there, right? Because we're just not simulating organism level physiological processes in this model. But there are also interactions, and those are much less understood, that might arise from the interactions of species. And those could actually emerge in the simulations, even if we use environmental response functions that don't reflect interactions at the organism level. If that makes sense. So it really depends on whether, whether we can learn about these interactions from the models or whether we have to know them in advance. That really depends on the ecological scale that we're looking at.
Thanks.
And feel free to ask. I feel like that was a little bit convoluted now. So feel free to ask again if it doesn't make sense, please.
Okay, I'm not seeing any other questions or any other hands raised. I think we're on nearly an hour anyway, so maybe it's not so bad. But I was just going to add to, sorry, Jeroen, I'm going to finish quickly. I'm just going to add that I think, having done some of this modeling before, one of the things that was the hardest is actually finding the data. And Christy was talking about salinity and temperature, for instance. You know, having some sort of understanding of the impact of temperatures has usually been easier than the impact of salinity on interaction. So I think that has always been, for me, the reason why we tend to work with fisheries, is because we have more data on that than with other things. So I think that's probably, I would have hazarded a guess that was the reason why there's not so much work in that sense. Yeah. But surely there's more data in in America, where they have lots of big estuaries to look at those kind of things. Jeroen?
Yeah, in that spirit as well, I think what you're saying is very true. We need all these things that should be done that we're not doing, and we must be not doing them for a reason. How would you like to kick the ecosystem modeling community into motion to really start being more open-minded to connecting different models? What kind of pathways do you foresee? Because I mean, you started this. It's good to see if you can develop at least a conceptual implementation roadmap. Like, do you understand my question?
I think so. I think so. If I don't understand it, it will be evident in my answer, and we'll try again. So how can we get people to actually implement some of those ideas, or put their own touches on them and move forward? I don't know. Maybe going out and suggesting these things will do a part of the job. That would be ideal. That's maybe also a little bit naive. So I hope that I will be able to have a few demonstration studies that show how these things can work out. And it's risky because there's also a chance that some of those things just don't work with the data and the methods that we have available now, right? So, but yeah, I want to try it, and if we have a few examples where it does work, I think that would be really helpful in getting more people to work in the same way. But we don't have them yet. Maybe I'll get funding, and in that case, I might be allowed to come back here in 5-6 years and tell you how it worked. Maybe I won't get funded, and then I hope that someone else is going to pick it up. But I don't know if that's going to happen.
Thanks, Andy. I don't know if anybody else still has another question, but I see that Kirsty already has had to go. I'm sure people are teaching and other things are happening. So if there is I'm not seeing any waving from the panel up there. So if there isn't any extra questions, it's just I just want to say thank you very much for a great talk. It was great to see. And I think indeed, we will be able to use a lot of this in the Ecoscope work that we're doing, Jeroen and Billy. So that would be great. As I said in the beginning, we don't have a speaker for January. So if anybody has a talk that they want to give, then please remind us, and I will set it up. And if there's nothing else, I think I will just say thank you very much. And in fact, it wasn't live streamed on YouTube because I couldn't get it to work. So we will put it on YouTube probably in the next day or two when Jeroen has a chance. And I'll send the link around. So, okay.
Yeah. Thank you everyone for organizing the seminar. Thanks for coming. It was a pleasure. So.
Thanks everybody.
Thank you.
Bye.
Very nice. Bye.
Bye.